Good afternoon. My name is Ankit Bajpai. I am working with tech savvy engineers since 3 years and I have done my graduation with mechanical engineering. I have total 5 years of experience. Now, my organization at a glance. We are authorized value-added resellers of SolidWorks in North India. We are also engineering and analysis service provider, and also we are training and support provider over SolidWorks products in North India. What is our vision? Our vision is to imparting innovative and leading technology solution training and development through effective partnership. And what is our mission? Our mission is to provide proper tools and technology to our customers so that they gain competency to meet varied industry challenges at the economical cost. Now about us, who we are, what we offer, and our presence. Now, who we are, as I have already briefed you, we are authorized reseller of SolidWorks product suite in North India. We are engaged in providing industry-leading training and support on all SolidWorks products, and we have also more than 15 years of experience in engineering, design, and analysis field by our dedicated service team. Now what we offer. This is the complete product suite we offer. You can see here we have solution from mechanical design to electrical design to electronics design like SolidWorks PCB layout designer, and we have also solution in field of technical documentation, data management, even in design validation with our simulation product like structural simulation, flow simulation, and different analysis products. Now, apart from this, we also offer design engineering services like 2D to 3D conversion, tool design, reverse engineering, data migration, FEA, CFD simulation services, design automation, etc. Apart from these two, we also serve as a training and support provider in North India for SolidWorks products. Now, our presence. We are present in North India with headquarters in Noida. We also present at different locations like New Delhi, Gurgaon, Jaipur with our dedicated offices. Today I am going to complete a training session over productivity tools part 2, as we are running a free SolidWorks training series with the name of Mastering series, and we are doing sessions on different modules inside the SolidWorks. So this productivity tools part has been planned with 3 sessions, one of which I already have been done, and the second part today I am going to show you. This is the whole agenda of productivity tools. And today I am going to cover this agenda of day 2. So today I will cover SolidWorks utilities, toolbox utilities, and toolbox library. Let's start with SolidWorks utilities. These are some utility tools. With help of those we can make some manual tasks automatic like model comparison, drawing comparison, drafting standard checking, analysis of the thickness variations, dummy part creation for analysis or top level assembly, etc. With help of these tools we can perform these type of tasks with few clicks within SolidWorks. Even some of the utilities are able to generate reports. These are some features comes under the category of SolidWorks utilities. Let's start with find and replace annotation. Let me show you what find and replace annotation will work for us. Okay. Find and replace annotation work for annotation used in 3D or 2D data like dim, expired, surface finish, weld symbol, note, etc. So let me show you what find and replace annotation will do. Quickly type find, and you will find different find features like find modify features, find reference, find replace. Now find and replace annotation. First provide a 3D annotation like note, top surface. I am going to change annotation view of this note. And now this command is active. So let me provide one more annotation like surface finish annotation. Okay, so I have added 2 3D annotations here. You can even use this command for 3D or 2D, both type of annotations. Quickly run find and replace annotation. I am going to type surface, and now if I press find next, you have not selected annotation filter. So this is the time to select annotation filter. I have selected surface finish, and then what will be the next? Okay, find next. Replace this surface spelling with face. We can replace multiple annotations in single shot. Now the next is find N and replace with N1. So these are some tasks you can simply perform with utility tools. Quickly move to slide. The next is find and modify feature. What find and modify feature will do for us? Used to search and modify features individually or in group. Find and modify feature. Just select feature in category and select simple fillet. I can edit parameter to define some range. Find now. I can also define which types of feature will be searched, like unsuppressed or suppressed. Now this is the time to observe parameters. This radius value is 6. I am going to change this. Even I can select multiple features and change parameters simultaneously for multiple features. Now I am going to change this 5 from 6, and if I have selected multiple features simultaneously and change parameters for them, then I can use modify all. This time I will proceed with modify selected. And the feature dimension is modified. Second one is 12 mm. This is the time to change this to 10 mm and modify. Okay, so this is how find and modify feature will work for us. The next is simplify. Simplify will create simplified configuration for use in top level assembly or for analysis purpose. Let's see how. Select filter as per your requirement, then simplification factor, then find. Now you can see as per the simplification factor 0.5, 3 fillets has been selected. Now I am going to suppress these fillets. When I suppress these fillets, simplify command will create a new derived configuration with suppressed state of these 3 fillets. Derived configuration. Now quickly switch to the parent configuration and quickly move to the slide. The next is power select. What is power select doing? Power select will enable us to select multiple features in single click. Like we can filter the parameters on different ways, like edge convexity, edge angle, face color, feature type. I am going to proceed with very simple filter feature type, and in feature type I will select fillet and search. So these are the fillets selected by power select. Now close power select and we can simply suppress all selected features in single click. So this is how power select will work for us. Now the next is thickness analysis. What thickness analysis will do for us? Thickness analysis will verify the thickness variation along whole part against the thickness range or thickness target provided by us. First, I am proceeding with thin region thickness analysis, and with default value inserted, just click calculate, and this is the time SolidWorks will perform a thickness analysis for me. Okay, now you can see here, this is the range chart. Change the value to 10, then recalculate. Now you can see the range chart is defined here and the model is color coded as per the range chart. You can see as this rib is drafted, that's why when you hover your mouse, the thickness is varying at different height. Okay, we can save this report folder name thin region analysis, and I am going to save this to the location. Even I want to show you that you can set your location as per your suitability. Now save it. On the same location, we will find the reports. Reports has been created. Even I can view these reports by double clicking on these reports, as these are HTML files or HTML pages. Report is opening. Okay, so you will find a interactive report generated by SolidWorks for thickness analysis of thin regions. Now this is the time to check thick regions, provide minimum thickness to some maximum value, and calculate the region lies under this region, this range. This is the range, color range chart, and the model is divided in different colors as per the color range chart for thickness. We can also save this report. Thick region analysis, and save this. Now the next command is symmetry check. Quickly run symmetry check. What symmetry check will do for us? Symmetry check will check the model against provided planar face or plane for the symmetry. Just click on check. Part symmetry check. What symmetry check results are showing? Part is symmetric about right plane. Now this is the time to check our part. Part is symmetric about the selected plane. Okay, you will see in result area there is no unique face, there is no asymmetric face. All faces are lies under symmetric face. Let me show you some different result. I am going to run symmetry check on this model with front plane. Part is symmetric about the selected plane. Now I am going to select some different plane like top plane. And now we will see what results will calculated by symmetric check command. You can see there are some unique faces, there are some different asymmetric faces found in this model with respect to top plane. That's how symmetry check command works. Quickly move to the slide. Now next is compare utility. As let me show you first. We can run compare utility on the similar type of models with some changes, like let me open a different version of this part. Now run compare document for 2 and 2.1. I can select for which parameter I can run compare utility, like document properties, features, geometry. If I am comparing assembly, then I can compare bill of material also. Now this is the time to run comparison. These are comparison results for document properties. For features, you can see for geometry, material to remove. This material is to remove this material in this model to make both model identical. Material to add. If you are not proceed with material removal, then you can add materials. And what is the common volume for the both models? So this is the compare document. We can run comparison for both assembly and drawing documents. Quickly move to slide. Now the next is geometry analysis. Geometry analysis is basically used to check the model for meshing process for simulation. So geometric analysis will help you to check your model for meshing. Different parameters against which we can check our model, like short edges, we can define range, small faces, we can define range, silver faces, we can define range. Silver faces are the faces with very high aspect ratio. Knife edges are the edges where two adjacent faces have acute angle. Knife vertex are the vertex where two adjacent edges has acute angle. We can provide values as per our requirement and calculate. Now this is the result area. Only 17 knife edges has been found. So this is how you can use geometry analysis. Quickly move to slide. The next is feature paint. Okay, let me open some model to show you feature paint. You can see in this model I have created 3 extrude features of different sizes. This is cut of 30 by 50. This cut is of 20 by 30, and this is of 15 dia and 20 dia, 15 by 20. And one of these cut I have already provided some color. So now it is time to run feature paint. Select feature from which you want to copy properties. Make sure feature paint will copy only feature properties, not sketch properties. Select this. Now this is the time to select the feature on which you want to paste the information of the seed feature. Now apply. As I have already informed you that feature paint will not work for sketch dimensions. So you can see the diameter of these holes has not been changed. Only depth, which is the part of feature, and color has been changed. Quickly move to slide. The next is design checker. How design checker will work for us? Let me create some drawing from this model. We can even check 3D model also, but I am going to show you the design checker in drawing. quickly place some standard views, change scale, call dimensions, and make some annotation beautification. Now, what design checker will work for us? Now, check active document. These are the options comes under design checker. We can check active document against standards like AMSI, ISO, BIS, GHOST. We can check this document against existing files. If there is a drafting person created a drawing with correct standard, then we can make this drawing as a parameter and check all our drawing against this file. Now I will also brief you how you can build your check as per your company standard. So I am going to check my document against ANSI. Let me check. Okay. What design checker will do? Design checker will check our documents against the document annotation properties like dimensional annotation, note annotation, font, arrow size, dimension placement method, different items which comes under the drafting standard. So these are some difference found as per AMSI standard. We can correct current item. We can also autocorrect all items. Then correct selected. The next one is arrow style, actual value, preferred value, correct selected. Note font check. I can also press autocorrect all, and you will find that font and different entities has been modified. So this is how design checker will work for us. Now the time is to show you how you can build your checklist. Select a new document and select items for your checklist like dimension standard. Define your dimension standard, like I am going with ISO. The next is arrow style. The next is unit setting. The next is note font. So I am building my checklist. You can see here. This is how you can build your checklist and save it as SOLIDWORKS standard or .swstd file. Basically, I have checked against ANSI, which is also a swstd file. This is how you can build your checks. Now quickly move to slide. The next is deviation. Okay, what deviation will do for us? Deviation will help us to create a simple model for third-party content publishing or top-level assembly utilization. Let me show you how. Run defeature command. Select the feature you want to keep. You can select items on different base. Now the next is to select the item you want to remove. I can also create defeatured model from assembly events. I can save this as a new document. I can link this defeatured model with the parent so that when I will apply some changes, the defeatured model will updated. I can publish my model in third-party content central or Dassault 3D content central. I can store settings for future. You can see the feature is added in my history. Whenever I will edit this feature and apply some changes, changes will be automatically applied to this defeature feature because I have made this defeatured model linked with parent one. The next is assembly envelope. Okay, let me show you how we can use assembly envelope. Let's say I am going to create some assembly. This assembly is my target work, and I have created some of the parts and some of the sub-assemblies for this assembly, like this crank sub-assembly I have created, this bracket I have created, and this male yoke I have created. Now what I want to check? I want to just check the alignment or other things without creating an actual assembly. For that, what will I do? I am going to open this part and create a temporary assembly document. And now this is the time to evaluate mass properties 56.36. Okay. Now I will call some items like crank assembly I have created, yoke mail I have created, and I will call these items as an envelope. So you can see envelope items are called in assembly area as a virtual item. You can see there is no contribution of these items in your mass property, even in bill of material also. But we can apply different references like mate reference or another references on these parts as actual part. So this is how we can use a part as a virtual part inside the assembly to check mechanism without creating actual assembly. Even I can change this state directly by clicking on properties and check on envelope. This is how envelope command will work for us. You can use assembly envelope more effectively from 2020 now. The next is report manager. What is report manager? Okay. Report manager is basically manage your all reports created from different SolidWorks tools. Just provide a location. I am going to paste this location and press enter. The both reports I have created are showing here. Just click on view to view any of the reports. Now quickly move to our slide. The next is toolbox utilities. So what are toolbox utilities? These are some utility tools with help of those we can make standard items and features like structural bar, groove, cams, etc. directly, and also calculate stress and deflection of standard beam in planar or 2D application. Tools that comes under this category are structural steel tools, cams, grooves, beam calculator, bearing calculator. Let me show you how we can use this. Quickly close this and open a new part, as at least one part document is required to run. Go in add-in and add SolidWorks toolbox. When you add SolidWorks toolbox utilities will automatically added. Okay, so I am going to start with structural steel. These are some standards provided in structural steel like ANSI, BSI, CISC, DIN, ISO, JIS. Just click on type of beam and select size and click create. So SolidWorks will create a same standard sketch for the same cross section. You can make this sketch fully defined by providing dimension against the origin by editing this sketch. Now the second thing, I can switch to the beam calculator directly from this, and this time which cross section I have selected, the beam calculator will calculate the parameters for the same cross section. As you can see, the section modulus for different cross section is different. Okay. So we can use both units like inch and metric. Now put some length, say 500 mm, put some load value like 150 Newton, and it will provide deflection. For this case, there are some standard case defined in beam calculator, like these are some standard cases for which you can make some direct calculations. For your stress, just provide length and load and solve this. This is the stress value. This is how you can use beam calculator and structural steel. Now the second one is bearing calculator. Just select bearing, just select standard, type of bearing, bearing size. Now this is the time to make some different calculations, like provide number of balls, provide ball diameter, and solve the capacity. And for this capacity, solve the life for different values of load. This is the life in revolution, this is the life in hour. Now put some capacity to calculate the life for rated parameter you have provided, like 10 balls, 1.5 mm diameter. Change the capacity to 80. Now solve life for different load value. This is how you can calculate bearing life. Now the next time is to run some groove. Let me open different part. I am going to show you groove. Two types of groove you can create inside the SolidWorks. One is O-ring groove, then retaining ring groove. Let me start with O-ring groove. Just select standard, select type of groove, select size, and create. You need to select a reference space for create the groove, and groove will be automatically created by SolidWorks. The sketch is underdefined. Just you can define this sketch as per your requirement. Like first, make this sketch dimension. Okay, sketch is defined, and now you can change the groove position and dimension as per your requirement. Similarly, I can apply retaining ring groove, standards, types, sizes, select reference, then apply groove. Here you will find the sketch is underdefined. You can define this sketch manually as we have already done before. Now the next is, inside the SolidWorks you can create two types of cams. One is circular cam, one is linear cam. Let me show you how. And you can use these cams in your assembly. Here I am going to a simple cam for example. I will start with circular, and I can select different types of followers. I will start with translating. Follower diameter will be 1 as it is, and starting radius I will put here 3, and the starting angle will 0, and the rotation direction will clockwise. Now the next step is to provide some motion. So first motion I will start with dwell of 90 degree. The second motion I will provide constant acceleration with ending radius 10 mm and motion range of 120 degree. The next motion I will provide a cycloidal with ending radius of 5 and the motion range of 60 degree. The next motion I will provide modified sine, ending radius of 6.5 mm and the motion range of 45. Still 45 degree motion remaining, so I will add one more motion, let's say harmonic, with 6 mm ending radius and 45 degree range of motion. The next step is creation, so I will choose create new part with track removed. The blank dia will 20 and blank thickness will 10. Near hub dia will 4 and near hub length 0.5 mm. Far hub parameters will be same as per the near hub. Now through hole dia will 2 and track type and depth will blind with 5 mm as it is, and resolution type will, let's say, caudal tolerance with the same tolerance as it is 0.002, and track surface is inner rather than both sides. Now let's see what it will create for us. Okay, I have to change the starting radius, as I have provided a large radius range for different motion. Now let's see what the tool will create for us. Okay, cam is created. Now this cam path is divided in facets. For using in assembly, what you have to do, you have just make this sketch smooth with the help of fit spline. Fit spline is making our sketch smooth. For cam motion, just set your tolerance and click OK. Now a smooth path is ready to select as a cam path. I can also use angular increment with some values and try to create a cam. Let's see what will be the result. So you can see the face is still divided in facets. We can make this smooth, not a big deal. Near hub dia, near hub depth. Okay. Now, the next task is to create a linear cam. I am going to show how to create a linear cam. Just select the linear cam. Follower, I will proceed with translating as it is. Unit, I will proceed with metric as it is. You can change it to inch also. Follower dia, I will proceed with 1. Starting rise, I will proceed with 2 as it is, and starting run 1 as it is. And cam motion is to left. Now motion, I am going to add some motion. I will start with dwell of 2 mm. Then I will add a motion like cycloidal with 8 mm rise. And what is the run distance? Let's say 7 mm. The next is also dwell with 4 mm. The next I will provide a motion along a constant acceleration curve with 6 mm in rise and 3 mm distance. Next is dwell of 4 mm. Next is modified trapezoidal with let's say 4 mm ending rise and 4 by 4. The next will be also a modified trapezoidal of 4 by 4. Now the creation, provide blank thickness 5, provide blank width 10, provide blank length 30. As you can see, the total motion is distance is 28. Now the track type is through and track surface is both sides. Resolution type is motion increment as it is, and resolution value is 1 as it is. Now let's see what will be created with these parameters. This is the cam we have created. You can make this cam path smooth for using in assembly. So this is how you can use cams. The next is toolbox library. Let me start with some assembly document so that I can show you how you can use toolbox, how you can edit your toolbox, and how you can customize your library as per your requirement. So here I have assembled 2 plates. One is with counter bore and other is with simple hole. But both holes has been created with hole wizard. Let me see the size of this hole so that I can provide some fasteners. Hex bolt grade C ISO 4016. This is the time to add some fasteners here. ISO hex bolt grade C 4016. Just place a fastener here. Description and part number is already provided here, or you can provide your own description and part number also. Like I am going to provide it hex, nut, size or number as per your company standard. Just control length. Put thread display cosmetic as schematic will take schematic will consume more system capacity. I can modify this range. I will show you in the customization. Now click OK. This is how you add the toolbox. Now how you edit the toolbox? Just right click on toolbox and edit toolbox component. Generate a bomb. You will find the part number is description or other information is added here. This is how you can control the bill of material information of the fastener. Now let me create a top level assembly by using this as a sub assembly to show you that in case of sub assembly you will not able to edit your toolbox, for which you need to open this assembly in its own window and then you will be able to edit the toolbox. Now what is the next? The next is patterning of toolbox components. Let me show you. How you can pattern your toolbox. Just create an assembly document from this for example purpose. Provide some fastener here. And now this is the time to check that you have provided these 3 holes in single command. So you can pattern this fastener in all 3 holes. Just select a feature to be patterned. Just select seed position. You can see preview appear here. You can decide whether your instances will follow the alignment of seed or alignment of hole. Now generate bill of material. Okay. Part number, description. This is how you can pattern your toolbox. The next one is smart fastener. Let me show you smart fastener. Just by selecting hole, we can provide fasteners from our toolbox library directly. So holes provided in one command will automatically populate with fasteners of same size in single click. We can provide some stacks here, as you can only provide top stack or top washer here. So only top stack command appears. For the same type of item, here you will find both type of stacks, a top stack and bottom stack. Just add some top stack like this and add some bottom stack like this. Okay, this is how you can use smart fastener command. So all toolbox components will come under the smart fastener folder. Now what is the next? The next is configuring your existing toolbox library. Okay, pretty interesting topic. By clicking configure toolbox, you will able to access your toolbox customization. Let me show you how. Here you can control different parameters, like the same for the same fastener, same grade as I have used. I can add part number and description before starting to use, or even I can add different a range of length for very same M8 fastener. You can see this is the length range provided here with thread length. I can increase this length by clicking add, or in this case of filling part number and description, what I can do, I can simply export this data and quickly open this data. Okay, here the Excel is exported. You must have installed supported Microsoft products for this process. Now put some part number here like A, B, C, D, 1, 2, 3, 4, 5. Then populate this with different values. Now this is the time to provide some description like A, B, C, D, E, F, G, H. Copy this. K, L, M, N, O, P. Copy this. Save this. And import this. You will find all information automatically filled here. You can add comments also. Just save it and enjoy it. The next is creating custom standards. Okay, let me show you how you can create some custom standards. You can add folder inside the existing one or inside the master folder. Like I am going to add a folder name ABCD, and inside this you can add folder or file. Even inside this you can add a new folder or file directly. You can add your configured part here. From here you can control different properties and save this by saving what you will found. You will find your standard inside this with your fastener created. That's how you can customize your SolidWorks toolbox library. With this, I am going to close this presentation. If there is any query from your side, you can reach us through this information. Okay, bye.